Stoichiometry is the part of chemistry that studies the amount of substances that are involved in reactions. So you start off with a balanced chemical equation to make sure that you can use the coefficients for your mole ratio. This is the equation to convert iron and oxygen into the product of rust. You start off with your given amount of 10.6 grams, and you're going to convert it into your product of Fe2O3. So you have a conversion factor here of the molar mass in grams under 1 mole. Then you set up the mole ratio between iron and the product of rust. The coefficients are used. Then you take 1 mole of Fe2O3 and put it under its molar mass in grams. Then you multiply across the top and you multiply across the bottom. Then you divide and you come up with the theoretical yield. This is your theoretical yield, but you don't know that. So you're going to have to use the other reactant, and you're given 15.12 grams of O2 and convert it into Fe2O3. So you take your 15.12 grams and you get the molar mass of O2, and it will be under 1 mole. Then you set up the mole ratio, which you will again use the coefficients. You'll use 3 from O2, and you'll use 2 from Fe2O3. Then you will set up 1 mole of Fe2O3 and put it under its molar mass. You will multiply it across the top, and then you'll multiply it across the bottom, and then you'll divide, ending up with this number. Now, because this number is less than the other product produced by 15.12 grams of O2, that means that this is your theoretical yield, and iron is your limiting reactant. O2, on the other hand, will be your excess reactant. Now, many chemistry teachers will ask you to find how much excess reactant is left over. So you'll have to take 10.6 grams of iron and place the molar mass of iron, 55.85 grams, under 1 mole. Then you will set up the mole ratio between iron and O2. You will use the coefficients again, 4 and 3. And then you will set up 1 mole of O2 into the molar mass of O2. You will multiply across and on the bottom. Then you will divide and you'll end up with 4.56 grams of O2. But this is the amount of oxygen used in the reaction. We will then take 15.12 grams of oxygen gas and subtract 4.56, because that's how much oxygen gas you are given, and that's how much that is used. You will end up with 10.56 grams of oxygen gas, and that is how much oxygen gas that is left over. To calculate your percent yield, you would place the actual amount of Fe2O3 that was obtained in the reaction over the theoretical yield. You will divide and end up with 97% yield. This is considered efficient because any percent yield above 60% is considered efficient.